Okay, so I lied in the last video and said it was the last video, but it was a little longer than I wanted, so I split it in two. So in this video, we're going to talk about trig functions, and we are going to talk about using those trig functions given a point on our coordinate axes. This is setting us up for the unit circle, so this is very, very, very exciting stuff. All right, so it says let theta be an angle in standard form and p x comma y be a point on the terminal side of theta. So first of all, let's look at our picture here. We have theta, boom, there's my angle, and there's my point that is on the terminal side, x comma y. Now it says the distance from P to the origin, R, can be found using the formula, and we're going to talk about that formula, but let's get it set up first. So what we're doing is we are going to do that reference angle. So we're going to be actually looking at this angle here because that's our reference angle closest to the x-axis. And we are going to form that right angle by coming straight down. Now, notice what that does. That creates this beautiful, guess what, right triangle. So again, what we're looking at here, we are looking at this as our reference angle and this triangle here. Now, notice that the horizontal distance is x and the vertical distance is y. Because the point x comma y, I went x to the left and y up. That's what I did. Now, the reason we have reference angles, you have to ignore the sign. We'll talk more about that later. But what's going to happen is you are going to be able to use your reference angle and the triangle that is formed to find your trig ratios. Sorry, my brain got distracted. To find your trig ratios for theta. Okay, so watch what happens. First of all, how would I find my distance r? Well, this is a right triangle. So I would do it with the Pythagorean theorem. X squared plus y squared equals r squared. The reason we used r, it's going to stand for radius because we're going to be doing, guess what, the unit circle, and circles have radiuses, radii. So that's why we're using that. Here's what we want to be able to do. Sine of theta. Instead of using theta, I'm going to use the reference angle. So instead of using theta here, I'm going to use the reference angle here. Okay? So sine is opposite over hypotenuse, y over r. Cosine is adjacent over hypotenuse, x over r. Tangent is opposite over adjacent, y over x. So doing this, I am using not theta, because I couldn't form a nice right triangle with theta, because it's obtuse. I'm using my reference angle, the angle closest to my x-axis. Okay? And then cosecant is just the flip of sine. Secant is the flip or the reciprocal of cosine. And cotangent is the flip or the reciprocal of tangent. Okay? Now, let's look at this with some numbers. That's an R in case that's not clear. Let's look at this with some numbers. So it says the point 5 comma negative 2 is a point on the terminal side of theta in standard form. Find the exact values of the trig function of theta. So here we go. First thing we're going to do is plot the point. X is 5, y is negative 2. So that's the point 5, negative 2. Okay? So in standard form, I'm coming around this way. Right? So let me neaten that up. Hold on. That's messy. There. Hopefully that's a little better. So that's the angle we're looking at. Right? And the 5, negative 2 is on the terminal side. Now, my reference angle is this angle here. And what I'm going to do is form a triangle that stops at that 5, negative 2. Here is the key. This distance here is 5 because I went to the right 5. This distance here is 2. Now, when I'm looking at doing this, I'm going to count it as a negative 2 because I went down. So the distance is 2, but I went down, so I need my direction. I need the negative to be in there. Now, the thing I don't know, which I'm going to need, is the radius. Or I'm sorry, the hypotenuse. Let's call it the hypotenuse because I'm dealing with a right triangle here. And that's my right angle right there. All right, so to find my hypotenuse, I'm going to do 5 squared. I'm going to ignore the negative for this because on this I'm just doing my distance. So I get 25 plus 4 equals r squared. So 29 equals r squared. Taking the square root of both sides, I get r equals square root of 29. That's a distance. That's just a distance. So I'm not even looking at the negative on this one. That's a distance, so it's just square root of 29. I don't do plus or minus because I don't want the negative one. I just want the distance. So that's the length of the hypotenuse. So again, the reason I'm dealing with the negative for my y is because directions-wise, when I plotted that point, I went to the right 5, that's a positive 5. I went down 2, that's a negative 2. Your hypotenuse is always going to be positive, okay, because it's just straight up a distance. All right, so that means that this right here is square root of 29. Okay, so sine. I'm going to use my reference angle, the one in red. Sine is opposite over hypotenuse, so negative 2 over 20, square root of over square root of 29. Cosine is adjacent over hypotenuse, so 5 over the square root of 29. Tangent is opposite over adjacent, so negative 2 over 5. Cosecant is the flip of sine, so square root of 29 over negative 2. Rationalizing my, I don't need to rationalize that denominator. I need to come back and rationalize the sine, which I'll do in just a minute. Secant is the flip of cosine. And tangent is the flip, or cotangent rather, is the flip of tangent. Now, I didn't rationalize my denominators. I don't like that square root in the denominator. So I'm going to multiply top and bottom by the square root of 29. And what I'm going to get here is negative 2 square root 29 over 29. And I'm going to neaten that up. And then the same thing for cosine. I need to rationalize that denominator. So multiplying top and bottom by the square root of 29. I am going to get, need to figure out how to default it to a thinner pen. 5 square root 29 over 29. I just forgot to rationalize my denominator the first time through. I don't like a square root in the denominator of my fraction. All right, that is it for using our reference angles and a point to find our trig ratios.